So can anyone talk like what did you got yesterday? The keywords, please.
Yeah, again we have revised about how gates work and how the cluster will work. What are the like how master and worker interact with the like kubectl commands and all. And even we have learned about deployment YAML and also service.yaml and what are the like commands we have. Lines we have in the YAML files we have written, like how we can write a basic YAML file for the service and deployment.
Yeah. So
And we have learned about
yeah,
please.
Yeah, Kate is manifest MLs. Yeah. Yeah, the YAML keyword people will call as a manifest also. Sometimes in Kubernetes, right? People will be saying it a manifest file, something like that. So that yeah.
Yeah, and we have learned like how Docker client and Docker server interactions, like the commands.
Yeah. Tools to install on automation server. What are the tools to be there in the automation server? Wherever you are doing.
AWS
Yeah,
CL, Docker server, kubectl,
config, kube config.
This is very important. Okay. This is very important. Next, we will come with the automation. There we would need that. This is very important. Okay. Keep it here. That is separate as well. These are the tools we will need. One more. And one more, na? From here, you are able to reachable to. You are able.
Authenticator. I am
authenticator.
Yeah, yeah. And from here, you are able to reachable to ECR. You are able to reachable to EKS, right? So you need one extra thing, na, for this automation server. It's not about the tool, but it needs something, right? It is able to talk to ECR.
YAML file, right? Deployment YAML.
Yeah, those are the kube config will be there, but I was talking about other thing. From this automation server, you are able to reach to ECR. You are able to reachable to EKS. You are able to reachable to S3 also. You are able to reachable to other AWS services.
Permissions, like
What is that is called? We have attached one thing, right? From this automation server, yeah, I am role and I am
policies.
Let's say for now, this I'll say automation server, for example, role, okay? Whatever the role we assign, but this I would need again. We will revisit, let me tell you, we will revisit from day one sessions to till now again in another mode, okay? So we will, in that time, right? It's not something like we don't do handcraft and all again. Completely write the code. Somewhere we will click the deployment something. It goes in a cycle. So that's why I would need all these tools again there. And one more tool, na, if you remember.
Terraform, yeah.
From here only we have provision, right? These things, everything.
Right.
So
right.
So just I'll keep it this note somewhere. We'll wait a minute. So these tools and all we will install whenever the new system set, new environment comes. By default, you should have all these things. No one will tell you this is your job. This is our job. Keeping the things readily. Now, yesterday, can you guys tell me, like, we did a kind of an build and deployment. What did we do for the two things we did? One is the build, another is the deployment. For build, what do you need?
We have static website. We have built a static website. For that,
we need a code plus
Docker file.
And then we built what did we build?
Docker build.
Build
We build the
Docker
image. Yeah, we build.
Image.
and ECR login.
We
And
push we
image.
push the image to log ECR.
When you are pushing image, how that Docker image tag should be there? Docker image URL should be
ECR URL.
ID, login
Yeah,
ID, or right, like Amazon ID with
tag.
name and the tag.
ECR URL / your repo name : tag. Very important. That is called ECR URL / your account URL, I can say. Then repo name : tag. Next, see, where are we writing the code?
Local.
Local. Then please
We
observe here, we are bringing from local to
automation server.
Unbound server. We did manually, right? We did manually copied,
Yes.
like VI editor something, right? So in
Right.
future we will avoid this approach. From somewhere we will go to one place. From there automatically will come to the automation server. That is the next step. For now we copied manually. Where did we copy it, if you remember? With the place?
Yeah,
Workspace.
we have created workspace.
That was in /opt somewhere. Okay?
Right.
Somewhere I copied it. We kept it here. Here inside that folder only you did Docker build, Docker something, all those things. And then this is build. Okay, build. Code, another name you can call is the CI. Another build another name you can call is the building image, another name you call as a CI. Continuous integration. Deployment, right? Only deployment. There is no build. That is called CD. Another name I'm telling right away. Okay. In CD, what did we do? In deployment, what did we do?
We deploy images.
Yeah, we have run the like integrated the kubectl and kubeconfig.
Yeah. You for deployment, what is the things you need?
kubectl and
You need
kubeconfig.
kubeconfig. We need access to the
Then we
cluster.
created
So with these two files, you should be able to get to the connection to connect cluster. How do you test? Normally connectivity is there or not to cluster. Simple command, any command you can run.
kubectl. Yeah, kubectl.
Use command or simple command, one command. You can run like.
Oops.
So able to get the output, yes. So here you should have a connectivity to the cluster with these things. Okay. Now you got the cluster connectivity. Next.
Then we have authenticated with the AWS some hyphen.
Image we need to.
This is where you logged in and then pushed the image. Then this is where you logged in everything.
Yeah, we have created and deployed YAML file.
Yeah,
We
exactly.
need to create YAML.
Create
YAML.
deployed at YAML. In the deployment YAML, tell me some syntax in the deployment YAML.
Okay.
Yeah, kind API version.
What is the kind equal to? Kind
equal to object,
deployment.
which object you are going to.
What objects you can take for kind?
Deployment, service.
Deployment object.
No. Only for deployment only.
Yeah, okay. Pod, deployment, and state set, demand
Yes,
set.
take resources.
Kind you can take.
Pod, deployment, stateful set, demand set.
There is a
replica set, a replica controller.
These we don't take. This we don't take. They'll create internally, but we don't. Last two we don't create at all.
Okay.
These are all theory interview point of view only. Okay. These two we don't regularly interact. They will create automatic. When you do deployment, right? Deployment internally will create a pod, right? Deployment will create internally one more object also, that replica set. That will create. Okay. That we don't. Why we need these things? These are all simple. I have image, and image has to go to the cluster. One of these we will go. One of these approaches we will go. Okay. Other than this, you can't deploy any image to cluster. One of these you should have it mandatory. Image. Okay. Now you deployed and then API version Somewhere you will give image, right? In the image, what do you give? The YAML. In the deployment YAML, you will have example, right? API version, kind, metadata, spec. Inside spec, you are giving some properties. You are giving some list keys, blah, blah, something. Inside that spec, in the image, what do you give?
ECR
Image,
component tag.
Exactly.
image name and tag.
ECR, URL, image colon, tag. To whom this info will go at the end? At the end, you deployed it.
API.
API server.
At the end,
At the
Right, at the end, worker node.
kubelet.
Yeah, kubelet.
So kubelet should have a permissions to pull this image. So worker node, if you go to the cluster, our cluster, right? Worker node will have these permissions by default. IAM role will be there. It will have a ECR policy. If you don't have this thing, worker node also equal to your automation server only. For example, worker node cannot pull ECR URL image, ECR image, it cannot pull. So by default, worker node will have this policy internally. When we create the cluster, right, by default, it can pull. Now, let me go ahead. We did deployed. Deployment object, you created it. In the deployment object, you told a keyword called replica equal to something, 1 or something, okay? Now, worker node will pull that image and then it got how many pods to be running something. It will run a one pod. Internally, it will create a pod object. Okay? Where is the information stored? Replica equal to 1, and then the pod image info, where that is being stored?
master node in etcd.
In etcd something, right?
Yeah.
Now if we delete this pod, let me go here. Internally, API server, scheduler,
Controller.
here it showed replica equal to something 1. That deployment should have it like this, it has been stored info. For this deployment, this replica should be available. By default, you deleted by default in the sense, by something you want to do some activity, you deleted this pod. Automatically, because what is the role of Kubernetes? Make sure that whatever given instructions, if you delete this pod, one more replica automatically will come somewhere in one of the worker node. That's what the management. It could be in same node. It could be another node also. If it is goes to another node, again it will pull the image. Again from the registry, it will pull the image. Okay. Cool. So you should have by this time clarity how to use the kubectl, how the worker node comes, VCR, how the image will be there. You should have mindset. What is the how to connect to the cluster, kubeconfig, importance, you should have that clarity. And then how to deploy an image, what is manifest, kind, what are the kinds are we will choose to deploy an image. There are few, these are the ones only, pod, deployment, stateful set, daemon set, these are the ones. Okay. These are the ones we will use to deploy image. There is no other options. Only these are the ones you have to choose to deploy. Now, after you deploy, right now we have chosen deployment thing. When you do deployment, internally Kubernetes will create one object called a pod. The pod will be in running status. If you delete the pod again, it will create it. That's what you should have it. There is one more deployment is pod is running. That would be good. But as an end user, if I want to access the pod outside, let me go here. How do you access as an admin pods? How do you access pods as an admin? How do you access?
Through like kubectl commands.
Thumb rule. Okay, that is, you need a kubeconfig. That's it. You will go to inside that and all, we can do that. But as an end user, right? End user cannot use, no? He'll use the browser. He will type a domain. The domain will go to the somewhere Route 53. In Route 53, something But where is the pod is running here?
In worker node.
Worker nodes.
Exactly, in the worker nodes. Any one of worker nodes. Okay. Here pods are running. Worker nodes are in which network? VPC.
VPC,
Right.
private.
Pods, they will create their own network again. They will be in another network. This is a pod network. I'll say KTS network. Internally, they'll create it. Why they will create? That's how the Docker will work. In the Docker, you have some network type, right? Overlay to, if it is same host, bridge. If it is multiple nodes, overlay one network to another, one node to another node. And then there is one more none, Mac VLAN. There are the types are there in the Docker network. Kubernetes, what they did, they instead of Docker networks, right? There is a like bridge by, how do you check it? There is a command, Docker network ls. This is a Docker command. In the Docker, these are the network types are there. Bridge, overlay to, if more, EC2s. This is for single EC2. When you install Docker, right, by default, this is the bridge network will be there. And one more host also. This is also for single EC2. And one more none, Mac VLAN, something. So what they did, these people, EKS or Kubernetes people, they took this concept. Behind Kubernetes one, what is running?
Docker.
Docker only. Same. They took this Docker networking concept. They developed one more network, the pod related networks, and there are the KTS networks, VNet, etc. Not this cluster networking one. There are the, what are those in the interview? The Elastic VNet. Networking with. One is the VNet. These are all the commands they'll configure for us. You don't need to install anything. These guys, right? Let me tell you. I'll tell you. This Docker network concept right now, where is our cluster is running?
EKS.
EKS, right? Now AWS guy, what he did, he took this networking concept, Docker networking concept, he developed its own EKS network. In the outside also, some people are there. No, I don't want to go with this EKS network. This network will not applicable for EC2 missions. This is applicable only to whom? Pods only.
Pods.
Internal pod networking. Okay. Say there are the other companies also. Let's, for example, VUNet, there is one company. They developed something called VUNet kind of. There is one more, man. There is Calico. Yeah, VUNet. Don't think with the confusing keywords. Just it's for interview point of view. Okay. VUNet. They have VUNet network. There is a one YAML. If you deploy, that will take care. That's it. Nothing much. VUNet. Here you see that example. See, download this YAML. Then if you want to change, just at the end, apply this. That's it. They will take care of that networking thing. So, and one more, they took the Docker networking concept. One more company, Calico. They deployed Calico kind of networking. But since we are in EKS network, EKS, right? We will use the EKS related networking thing only. So we will see practically, wait for some time. My objective is here. If you want to access from outside, see here, this is the flow. Okay. Yeah. Route 53, my worker nodes are in this network. Let me keep it here. You are in outside. What is this outside? You are in internet. If you want to go to internet into the pod network, you need to go first VPC network. Here you will have a load balancer. We'll create one load balancer. This load balancer will be which network? Pod network or VPC network? Load balancers, AWS load balancers.
VPC.
From here, we will enter into their pod network. That How do you enter? You remember in worker node, in worker node, there is a, in worker node, two components will be running by default.
Yeah.
Kubelet,
End proxy
kubelet and
and network proxy.
kubelet and kubeproxy. In worker node, you know two things, kubelet and
Proxy.
proxy. Let me ask you this question. Why do we need a NAT gateway?
To access
To allow
outside.
the outside
Can I say like
command
this?
string.
That is the
Yeah.
bridge. That is the bridge between outside to within VPC.
Yes.
Yes.
VPC. This is the NAT. Gateway is the bridge. This is the internet. This, can I say it? Same
Yes.
internet to VPC. Who is the bridge between?
NAT gateway. Sorry.
Internet gateway.
This is egress. This is ingress.
Ingress.
Same way, when you're coming outside, right? Now you are in which network here?
VPC.
Here also?
VPC.
VPC.
When internally, whenever load balancer send a worker node, right? In the worker node, we will create some in the worker node, there is a component called kubeproxy.
Kube.
This will handle it based upon your request, on which port number your request is coming, on which header. This is the guy will act as a like this in between. The kubeproxy will take outside traffic to internal to KTS. That will convert it. Okay. This is where the conversion will happen. So this is altogether one network. Keep it here in the pod network, right? Any one they will use, not the bridge, not overlay and all. This one of they will use either EKS network, ViewNet, or Calico something. In on-premises, they'll use this guy, Calico. In the on-premises, I have seen it. But in the cluster, in EKS, we don't touch any component. These are all already there for you. They already set it up for you. Okay. Just you need to know theory in the interview point of view. Why do you need to know? Because there is a one pod network will be there. There is a one VPC will be there. The kubeproxy is the one who will bridge between VPC network to pod network. The kubeproxy is the one who will bridge that thing. That's where you keep the theory for now. This is the guy. Now request comes to worker node, load balancer will send internally worker node. Whenever request comes to the worker node, who will pick that? Kubeproxy. Kubeproxy will send to pod internally the request. That is what you keep this theory. This is any thoughts you want to ask on it. We are going here only right now. We are good with this flow. We are going with this. Now, keywords are little complex, but we'll get it to. This is the flow. We are going to experiment with this flow. Okay. Now, so this is the flow. I'll repeat it. Please don't hesitate. This is how the keywords will come. You deploy deployment object, which is one YAML. Just YAML. This is the definition. Definition in the sense, this is not running. Deployment won't be in running. This is the deployment object. You deployed it. Let me keep it in the deployment. When you say deployment keyword bigger, right? This is called kind. Okay. We did deployed. You gave the YAML. Internal, it will create what?
Pod.
Pods. Where the pods will be running? Obviously in the worker node. Now, as I told, right? Pods you cannot access from outside. Thumb rule. Pods you cannot access. Let me tell you, you think pod equal to EC2 only. So EC2s are in the private VPC, your own VPC. Can you access outside? Can I access EC2 from outside as an end user, which is in VPC, which is in private subnet?
No,
No.
Why?
you don't have permission. We have not allowing. If you have endpoint of load balancer, you can.
No, there is one thing you should know. It's not about permission. You cannot, let me put it here in the notes. Okay. I have EC2 in the private subnet. I can't access outside. Why?
నాకు రాహే కటింగ్ కొట్టి తీసి.
You need elastic IP.
Sorry. Can you say again?
You need elastic IP to access this.
Okay.
If it is
No, I told very clearly.
private subnet, EC2, I can't access it.
It's in private subnet, we cannot access outside.
Why?
It will have the private IP. It will not have the public IP.
Exactly. It will have a which IP?
Private IP.
Private IP. Same way, pods also, you remember pods you cannot access outside. Let me put it here. Pods also will have a private IP. And they are also in which subnet internally? Pod, where it is pod is running? Where the pod is running?
Worker.
Worker?
node.
No. Worker node. Worker node is nothing but what is this guy?
EC2,
They are also in which network?
private
Private.
Private
subnet.
Can you access this pod outside now?
No.
No.
You cannot access, right? Because they are thumb rule, they are in which network? Private. They will have a private IP. You cannot access this and all. Let me put it here. Here also private IP. You cannot access outside. Only the way you can access these guys are, you remember, you need to have a, in the EC2, what did we do for this thing? We created a one guy. If you remember, what is this guy?
Load balancer.
Balancer in the public. We created load balancer in the public subnet. We attached those private EC2s. We were able to access it. Here also, we need to create a load balancer. Yes, we need to create a load balancer, and then we will go through. We will go here. No. 1 second. If you want to access pods, yes, we need a load balancer because pods are in private, worker nodes are in private. But there is a complexity. Again, you are going to which model? The olden days model, right? You need to know, you have to create a load balancer. And then you have to create which guy? Target group. And then you need to know the pod port number. And then mapping them here, you need to create a listener. All this complexity, you are going to the old model. What AWS given you, I mean to say Kubernetes given you, you don't target on these guys. You give me, there is an object called service. Kind equal to service. So there are the types are there in the service. One is like type equal to, you can say like this, load balancer. And then you write a one YAML for this service.YAML. Obviously, this will be thumb rule. What is that? API version. This is our simple snippet. V1 or V2 will be there something. And you have to say type equal to load balancer. Now, there will be many deployments, many pods, many resources will be running in the cluster. Now, which you have to select here. From this load balancer, which application you need to access, here you have to select here. In the spec, you have to select something, select backend. Very important. How this pod has been created in the cluster? How this? Because of one object. Which object?
Deployment object.
You need to map that deployment name here. Both should match the deployment name and then the pod related. Exactly. I would say that deployment name, this service name, both should match. Now, what will get created here?
Load balancer.
Load balancer. Here you have to specify here extra things, little extra things here. What in this pod, in this pod, we have yesterday whatever we deployed it. What server you are running inside that pod? You are running one server. Okay, I'll say application.
Apache.
Exactly. Apache. You can call Apache also server, okay? Apache. I'll say one more. We'll say Apache server or one more keyword, HTTP server. On which port number?
80.
80. You have to say like this keyword here. Target port. Specify like this. You remember in the Docker what we used to do? Docker run -p OS port colon container port something, right? Instead of that thing, na, here I'll specify like this. Just I'll specify like this target port equal to 80. That this target port, whose target port? This deployment related thing. Here I have to specify like this. Can you guys tell me how service will connects to pods? How this service is connecting to these pods, for example, in this.
Proxy.
Yeah, that is internal, yes. Qproxy obviously will come. This is where the Qproxy will, this definition will go to Qproxy only. But here only I'm giving it. In this, somewhere you are telling it.
The backend.
When you say service, it's automatically internally talks to pods.
True,
Which pod
but
and all, yeah, which pod and all
Port
is
number.
backend. Here it will be there. Mentioned. We mentioned match about the deployment name, right?
how these pods created? How these pods created?
By using deployment
Using
object.
deployment object.
So here, yes, exactly. In this service, where are you specifying which deployment?
The backend.
Backend. So internally, now if you deploy this YAML, what will get created? We have told somewhere to create something.
Load balancer.
Load balancer.
So who will come create now? Load balancer will get created it. So no need to touch anything, no need to assign anything. That Kubernetes will take care. That's where the beauty. Load balancer automatically will come. You just give this YAML. That's it. Now I want to go with ALB, NLB. Then you have to specify something here. There is a section called annotation. After metadata, it will come. In the metadata, here you have to specify annotation. In the annotation, you have to specify what is the type, ALB or NLB. You can specify like this, which kind of load. By default, it will bring the classic. That need to be checked if they change something. But we used to get the classic load balancer. Now you will get a load balancer. Now go to old model. Whenever request comes to load balancer, go with the classic only. Classic load balancer will forward to whom behind? Request comes to load balancer, then load balancer will forward to whom? Okay, go with the ALB only. Okay, let me put it here in the notepad so that it will be. In the VM model, okay, you have a load balancer. Go with the classic only, CLB. Directly, we will have a EC2 here. In ALB, you will have an extra guy called
Target.
in classic, there is no target group. Directly, we will have a. Here, NLB also same. Here, extra things, what do you have? Rules. Here, there is no rules concept. That's it. That is the difference here. Now, you got it right here. Earlier days, if you sent a load balancer will have a listener. It will forward to automatically to that port internally here. Now, same way, let me put it here. Same way you deployed the service object. Why do you need service object?
Yeah,
To access the pods which are in private accounts.
Exactly. Pods are in which network? Private.
Private.
Why? Because the nature of the Docker, right? Docker will maintain its own network. In KTS, they made one more networking like VNet or EKS network. When you deploy it, automatically pods will be in the private network, and then the workers also in the private network. You cannot access them outside. So since Kubernetes given one option to access them outside, can I do manually creating a load balancer? Can I do that? You can do. You can do that. The manually port forwarding, you can do that. That's again, you are going to old model. That's where that is time taking process. You give me the YAML, that will take care everything. In the YAML, what is the kind you have to do to access the pods?
Service.
Exactly, service. You say load balancer. You tell me which deployment you want to get. Tell me the target port number. This is the definition, basic definition. Now Kubernetes will create a load balancer. It will, how many worker nodes were there? For example, 10 are there. Let's say, for example, it will attach 10 worker nodes. It will attach all of them, worker nodes. It will attach all the worker nodes based upon the load balancer. Let's say if you specify here ALB or whatever something, automatically all this will get comes. Automatically this target group will come, everything. You don't need to do that rules. Now, 10 worker nodes will come. In one of worker node, pods will be running, right? Pods will be running. Now, you remember I told right last time, in the VM model, you have two VMs. Let me put it VM1, VM2. Here I'm running in the VM model 80. If I say like in the VM model, VM2 colon, IP colon, whatever like, let me say 8080, okay? Colon 8080. Will it work in the VM model? Will it work in the EC2 model? Where is 8080 port is running in this example?
VM1,
VM1. But with what IP address you are accessing here?
VM2.
Will it work in the EC2 model?
No.
It will fail, right? But right now we are in the Kubernetes culture, right? So in the Kubernetes culture, what will happen if you access like this? If you access like this, internally kubeproxy will take care of that. It will find it. Same way, when you deploy a service, right? The load balancer internally will send to worker node. In the worker node, who will be running?
Kubelet. Kubeproxy.
I mean, I'm not telling on the yes, kubelet will be there. Kubelet job is to pull the image. That my job is to know how to access a pod as an outside. Now, if you access on the load balancer specific port number, that will go internally to worker node. In the worker node kubeproxy, it will check all your headers. What is the thing on which port number you are coming? Then it will find one of the node. Internally, the kubeproxy will take care. How kubeproxy will take care? Kubeproxy will have this info. Which info? This info will be there. And what is the target port and what is the deployment name, matching name, that internally will send that request to those pods internally. That's it. Please, I'm repeating again. Kubernetes is EC2 is the physical component. Kubernetes altogether is the virtual. You have to connect the dots. Simple dots are, I'll tell you. Pods came because of deployment. Now pods are in private. Nodes are in private, worker nodes. You cannot access outside. You need a virtual object, service. Service automatically will create a load balancer that it internally will send to kubeproxies. There is no manually, we don't go to worker node, we don't run ps-ef, nothing. Just give the image. So my objective was, you have to connect the dots. Let me put it here. As an end user, you will access with, you will have a browser and you will use the, let me put it like this. You will use the domain. We'll go to the Route 53. In Route 53, we'll have a load balancer. How this load balancer got created in KTS?
Through
Service.
deployment service Service object.
You created a what?
Service
Service.
object.
Service object. What did you say service type equal to?
Load balancer.
Load balancer.
What did you say here? Load
Load
balancer. Because of that, load balancer got created automatically. Now, the service will select to whom?
Deployment.
Service is selecting to whom?
The backend
What is this? What it is selecting?
deployment.
Deployment. Exactly. Service will internally will select deployment. Because of this deployment, what got created?
Load balancer.
Pod created.
Pods.
The report.
Pods. Because of this service, who got created here?
Load balancer.
Load balancer. Because of this deployment, what got created here?
Pods.
Pods. Internally, what happens here? Let me put it here. This is how the request will go. Internally, yes, you will select the deployment. These pods automatically they will register to service internally. Okay. Yes, deployment will be there, but you cannot see that deployment kind of. These pods automatically will register to service. Where the pods are running?
Worker nodes.
Worker node. Okay, I'm little making okay. One more refinery. Now automatically, yes, service will be there. That will be behind. Now see, to load balancer, to load balancer, who is getting added here? Internally, who is getting added at the end here? Who getting added here?
No.
Who are getting added automatically here?
Pods actually.
Worker nodes, exactly. Yes. Yes. Let me go here. In the worker node. In the worker node, what is running?
Pods.
Pod, yes, pods will be there along with the pod. Who will be running?
Proxy.
Proxy. Now, when you send a request, right, it will go to load balancer. Load balancer will send to worker node. These rules automatically will come because of this guy. They'll get created. Why? How load balancer got created? Because of service. Now, it will go internal queue proxy. Queue proxy will find where is the best, where is the pod is running. That they'll take care. Okay. This many layers will come in your request. Any thoughts you want to ask on it? So, what is the object you need to access the pods? Without that object, you cannot access the pods.
Service.
What is the pod?
Service object.
Service object. Without this service object, you cannot access pods outside. Why?
Inside.
In private
Means
network.
pods are in private network.
Pods are in private network.
You can't access pods without service object. Yes. Why? Thumb
In
rule.
private network.
Because pods are in private network.
That they have their own network and also who are network? Worker nodes also in
Private.
that is the one. What is service object? Please in the interviews they'll ask this question. That's what I was more focused on it. So what is service? Service is the entry point to access the pods. Okay. So it's a virtual load balancer. I'll say that. Service equal to virtual load balancer. Virtual. And it is entry point to access pods. What service will select? To whom service will select?
Load balancer.
No, what it will create? No. What it will select?
Deployment. Pods.
Deployment object.
Yeah.
Selects.
Service will select deployment objects. It can be like a pod. It can be this deployment. It can be one more. What is that?
Stateful set.
This will select. Because of these pods, right? They will get created pods, right? Service is a virtual load balancer. It is entry point to access pods. Service will select deployments. Pods will get registered to service. That we will see. Okay, practically we will see. This we will see. Whenever pod will come, right? That pod automatically, like when you create a EC2 mission, right? They will go to load balancer. Na? Same way, whenever you create a service, it will select the deployment. Because of the deployment, pods will be running. the pods automatically they will register with those into service. This we will see practically. Okay, good. Now there are types. Are there service types? What is the one type you have seen? Theoretically, I was telling one type.
Load balancer one type.
ALB, CLB.
What is this guy type equal to?
Load balance.
One is the load balancer. One is the load balancer. All my objective is how to access the pod outside. That is what my theory. Okay, that is what my focus currently. One is the load balancer. Second, node port. Node port will come on it. Third, cluster IP. Fourth, none. These are the types are there. What is the node port means? Let's say I'll take like this, same only. I'll say same. I'm targeting on the second one. Okay. Here, instead of load, here I'll say that this keyboard. I'll say that node port. Now, where the pod is running?
Pod is running in worker node.
Worker node, sir.
Worker node, right? You are saying that this is very clearly. You are saying that access service will select to whom?
Deployment object.
Because of deployment, what got created?
Pods.
Pods. So you are saying that pods where are it is running? I'm repeating
Worker
this.
node.
Worker node. You are saying that these pods, obviously service will access pods, right? Internally. These pods, I will access with the node IP. What I mean, like I was telling here, for example, like this. Like this. I was telling you right somewhere here. Okay, let me put it here. I will access HTTP colon. If you decode it, you have to tell me this answer, okay? I have worker nodes like this, okay? Worker node 1, worker node 2, worker node 3, okay? My pod is running here. My pod is running. Inside pod, what port number running? 80, okay? Here it is running. And I deployed this guy, this service object. I told what is this guy? Node port. If you say node port, right? There is no load balancer. Very clearly they are saying you can access only via which guy?
Port.
Here, they're saying very clearly one keyword.
Node.
Node. Do you have load balancer here?
No.
Nodes will have what? Every EC2 mission in access point of view, every EC2 will have a what? IP address, right?
IP address.
You think it now. If I want to access this, how do you access normally? HTTP.
Colon. IP address.
In Kubernetes, you know, right? Like this, you can access, no?
Yeah.
Colon.
Port number.
Obviously, by default, on which port number it will enter?
80.
80, right? It will enter. Now, request will go to whom? Internally, to whom it will go? Access point of view. In worker node, one guy will be running. Now, who will be running? Queue proxy.
Proxy. Yeah.
That will take care now. You can, what it mean? Here I'll say one more. Target port, right? Here I'll say one more port. Something like 30,456. You remember in the Docker run concept, right? Used to do Docker run, host port, colon container port, right? This is the port I'm saying it. This is called host port. You can specify or optional. If you remove, right, automatically one port will get assigned. That Kubernetes will take care. What I mean, if you go with the node port, never specify port here. If you specify it, you need to manually track it. That Kubernetes will do now, OS port and all. Now, here you will specify something called node port. What did you deploy? What is the object you deployed now? What is this object?
Service.
What is the service type?
Node port.
Service will select who?
Deployment object.
Now, if you deploy this, right, you will get a node port number. For example, like this, you can see that if there is a one command, you can see that port number. You will access like this. That internally will forward here. But in the real time, this will not work. You cannot access this somewhere because of one thing. You have to tell me. But end user cannot access like this. He knows it port number, but end user cannot access. From internet, he cannot access it. Why?
Because it's in private network,
Exactly. Who
Because
is in private network here?
worker nodes and
Exactly.
ports.
This IP end user cannot access outside. So one concept will not work for us.
node port.
If you go with the node port, you cannot access these ports outside, but you can access this within the VPC. Within the private network, you can access it. But so think that there is a one type you can access like this also. There are the service types are there. One is which type? Load balancer. One more is the node port. When it will not work? But it will access where within the
Private
it works within
Hmm.
where?
intranet.
Within VPC. Yeah, exactly. You can intranet is you can see that. Okay, good. So one is the node port. Node port thumb rule is there is no load balancer. You can access only with the node IPs, node host IPs, and then the one node port will come. You have to access it. That's it. Next, one more. It is very clearly saying it. You can access only if you go with the service, right? One more. 3. Let me put it here. Service type equal to what is this guy?
That's right.
Very clearly we're saying it. You remove it here. Now, is there any type did you specify here? In the
No.
by default, service type equal to cluster IP. By default, if you don't specify it, by default, service will go as a what type? Cluster IP. Very clearly it is saying it. This, whatever the pods attached to this service, whatever the deployment you attach to this service, those pods you cannot access outside, but you can access within the
Cluster.
cluster. One pod to another pod, you can access it. In the interview, right, they will target like anything on this area. They may ask you like what are the service types are there, but they'll ask you this question. Let me put it here. They'll give you like this example. Yesterday, you remember, I gave in WhatsApp one image, right? Can someone recall it? That flow? There is a one. Front-end was
Front-end AngularJS,
there was a
Backend and DB.
backend was there.
Java,
MongoDB was there.
MongoDB.
MongoDB was there. Now, please, this is where you deployed this deployment object. This is the deployment object. Because of this deployment object, who are running? Pods are running. You deployed one more object, deployment object. Because of this deployment, who are running? Pods are running. To access from front end to back end, each pod will be different IPs they will have. If you delete the pod, gone. The pod is gone. Again, you need to get that IP address. You need to register here. Okay. You will get to know the keywords. Just listen here. With the theory, I'm not caring about on this guy. I'm concentrating on this guy. This is the one service. This is the one service. Because they'll ask you very clearly on this. You should have this mindset in the interview. Cluster IP. Okay. Very clear it is. Why do we use cluster IP? Within the cluster only. If one pod want to access with another pod, in this case only. Okay. Now, I deployed 2 deployments. One is front end, another back end. How many deployments ML you need here?
2.
2. Front end, back end ML. How many images you need? How many images you need?
So,
How many Docker
2
images?
images.
2.
2. Replicas, it's up to the count. We don't care. Now, you tell me, here one object you need to access this guy. Otherwise, you cannot access from here. In between these two, you need one object. I was telling very clearly. Okay, I'll keep it here.
Cluster IP.
No, object. I'm not asking the type something. You need one object. To access the pods,
Yeah, service.
Service.
Exactly. You need a service. Now, this service, if I say load balancer, I can specify, yes, I can specify load balancer. But you are sending this packet again. I wanted to connect from where to where? Front end to back end. I will take this load balancer. I will give it here. Again, you are sending your traffic to outside. It will go to internet to load balancer, it will enter. So why do you want to send that from front end to back end? Because that's how the objective. They have this clearly objective. They wanted to connect from where to where? Front end to back end. Instead of specifying service equal to load balancer, node port, don't specify anything. By default type is what is that? Cluster IP. Give this service name to this guy. Configure here, backend. If you give this name, right, developer will configure here inside the code. Now, front end internally will call this backend service name. You are not calling the deployment. You are calling to whom? Front end is calling to whom?
Service.
Service. This service will internally will send to pods.
Yep.
So if you say service equal to cluster IP, you cannot access these pods from where?
Outside.
Outside. But they will work
Internally.
Internally with
one pod to another pod and all. So this is the one case. They may ask you, when do we go for cluster IP? Let me tell you, you already in the real time you are already using this. Okay, let me tell you. I'll tell you. Okay, you are already using. You went to Flipkart page. Okay, in the Flipkart page, you think this is the microservices or monolithic? What is the culture nowadays in the market?
Microservices.
Microservices.
So when you say microservices, different pods, right? There will be mobile pods will be running. There will be electronic pods.
furniture box.
For example, yes, there will be behind. Like when you're accessing Flipkart, are you directly going to the mobile related or home page?
Homepage.
Homepage.
This is also one pods. Okay. This is also one. Home page is the one pod. Please, here is the clue. There is a one more contact center. All these pods, can you access directly from Flipkart homepage? Can you directly access contact center pod only? I cannot see. I don't want to see mobiles. I don't want to see electronic gadgets page and all. Can you directly access contact center page?
Yeah, if we have a button, we can access that. Yes.
But
The
currently,
No.
if you want to go to the contact center, you need to go by one guy only from here.
Homepage.
Homepage, right? Now,
Yeah.
this is where here. This is the guy is the front end guy. I'll say this is the front end. These pods, can you access from outside? These pods got created because of which object? I was very clear. Pods got created because of one object.
Deployment object.
Deployment object. That is the thumb rule. This also got created from deployment. This also got created deployment. This also got created deployment. Now, from front end to, I want to access these pods. From front end. Thumb rule. If you want to go to the pod, via you need to go one guy. Via which guy?
service guy.
So here also I'll create one service object. Here also I'll create one service object. Here also I'll create one service object. The individual service object of mobile service, separate ML, separate deployment ML. Okay. Now, these service types, these are the ones. These are the types are there. You have to tell me.
If it is outside, it's load balance service type. If it is inside, it is a by
Yeah.
default cluster IP.
Yeah, exactly. Which in these applications, this is also deployment, obviously. Okay. Which one do you prefer load balancer in all these service types?
Can you please repeat which one?
Repeat again.
Okay, 1 second. In these deployments, you deployed multiple service objects also. Why do you need service objects? Thumb rule. You cannot access pods outside. If you want to access any pod, you need to go via service object.
Service.
That is the thumb rule. Will come more clearly. Just keep that thought. Okay. In this, you have deployed among these. You will go one deployment or one service as a load balancer among this. Which one do you prefer?
Home.
Remaining ones?
We can keep internal proxies.
Yeah, what is the one do you prefer? These are the service types are there.
Cluster IP will
Cluster IP will keep it. So by default, it will.
So one, you are getting a security right for these ones now. If you access cluster IP, pods are in which network by default?
VPC, private network.
Private network. So one is, if you go with, yes, these are no need to expose to outside. Can I expose this one as a load balancer if I wanted to?
Yes.
Can I
Yes,
see service
if you
able
want
to-
to can.
But what are you making? More, there is security,
Secure.
someone, they can enter also, right? They can breach. So that's where I'll make this. These are the ones. Why I need to go for cluster IP? Why I need to go for cluster IP?
They're internally connected.
The approach is this contact center can be accessed via only which guy?
Homepage.
From home page.
So homepage is running where? In the cluster, in the pod. From here to I need to go, no need to go to the load balancer. I can go via cluster, internally cluster network
Clusters.
only. That's where we will say as a cluster IP. Cluster IP is the default. You no need to specify. No need to specify. You need to specify. Now, here is a very clear. Any thoughts you want to ask on it? We will.
So here all the internal page, you can say as a pages, for example, mobile or okay, you
Yeah.
are keeping into the cluster IPs like private network,
Yes.
and whatever the main home page or domain, okay, you are keeping in with load balancer, you are accessing all these internal pages like
Yeah. The rest of these hyperlinks, right? These
Yeah.
hyperlinks, they will get access internally. That
Yes.
homepage will handle it. Yes.
Okay.
Yeah.
So there is any other name for cluster IP? Like I heard some Istio proxy something. So
No. Istio is another altogether different story. No.
okay.
No. There is by default no service altogether. This
Understand.
let me show you. I'll go to the official page. Something they added. Services and Kubernetes. Defining a service. Did they told any here? Anything here? Any type?
No.
So by default, what type it will be?
cluster IP.
Cluster IP.
Cluster IP.
Yeah. Default is the cluster IP. Now you can specify port definition. Don't care, please. You no need to by heart this. The VS Code will give you this snippet. No need to go. Service without selector. That's okay. That are the types are there. Cluster endpoint slices. Point slices, multiple port. You can, yeah, these are the ones. One is the cluster IP, node port, load balancer, external name. That's okay. This is map that contains up. You can think. Let me check on it. Okay, I'll check on it.
Okay, no problem.
One is the cluster IP. Yeah, these are the ones. Like we don't go with these concepts. Fairly, we were using all those cluster IP. These are the ones. Cluster IP we use based upon use case. Also, we went with the node port. We will also do in our lab load balancer. These three we were using it majorly. I can say these three, and one more none headless service. Okay, these are the ones there. One more they'll say as a this is the headless service. Okay, let me tell you. I was telling one keyword if you remember. Service is a called virtual load balancer. You know already know some objects. Okay. Pods. How pods got created? Because of which object?
Deployment object.
Okay. Going forward, I'll hide this keyword. Okay. You should know. If you want to access these pods, you need one object. What is that object?
Service object.
Number. This service object can be any one this now. Let me go with this in old model. You know EC2. These EC2s are in the private network. What is the one guy you need to access this one? Go with the VM model. In EC2s,
Bastion.
Load balance.
what is this
Load
guy?
balance.
Load balancer. Now, when you send a request, I have 4 EC2s. 4. Okay, 4 count of EC2s. Okay. If you send a request to load balancer, will load balancer will send that request to 4 EC2 machines or 1 EC2 machine only?
One is
Only one.
1 EC2 machine only, right? This is how.
Yes.
Beauty with this one, I was talking on this guy. If you go with the service equal to same, I'm comparing it. You told service equal to none. This is called headless. We call as headless. This service will send obviously to request to whom internally?
Pods.
Parts only. Now, if you go with this, right? If you say 4 pods are running, for example, okay, 4 or 10 pods. When you access this service endpoint, service is, I was telling, service is equal to virtual load balancer also. If you access this service in VM model, one EC2 machine only was giving the response, right? But in this model, right, if you send a request to service, it will send to 10 pods. At a time, it will send to 10 pods. That's what this headless service. Now 10 pods will accept that request. Then they'll store some kind of data, something. There is a specific use case for this. Why to go for this headless? Keep this thought. In headless service, if you say none, whatever the pods are running, all they will get a request. All they will get a request. There is a use case for that. For now, just keep it. That all pods will get a request in this headless. But if you go with the cluster IP or node port or load balancer, one pod only will get a request. Service is called virtual load balancer. So now you know you deploy a deployment object, but because of the deployment object, pods got created, but you cannot access those pods outside. Mandatory object, which object you need? Service. These are the service types are there. Load balancer, node port, cluster IP. Now they have one use case. Please tell me. I have A, B, C. A only to be accessed outside. B and C should access from only A. What type do you prefer in this service?
Cluster IP.
Cluster IP.
Cluster IP.
A for load
A
balancer.
will be load balancer. B and C will be cluster.
Exactly. This is how they will ask you this. This BC will accessible only from whom now?
Load balance.
Yeah, load balancer.
No. They will access only from
Yeah.
A.
we will configure here. We will give it to developer. This service name developer will configure in this code, in the A code. Any thoughts you want to access service? Without service object, you cannot access pods outside. Thumb rule.
So you said four pods are there. If
Yeah.
I have, for example, 1 lakh or 2 lakh, for example, pages like mobile, there also you can follow similar methodology.
One second. Let me put it here. So you mean 4 pods are running? You mean?
Yeah. Here 4 pods you said, mobile and whatever the other pods. Okay.
Just a minute. Now, one is the mobile pod, you mean?
Yeah.
One more? Let's say electronic.
Yeah, electronic.
One more like let's say.
No, he's saying if 1 lakh connection pages are there, then how I can connect? That's what his question.
Yeah.
The 1 lakh pages.
I'll come 1 lakh pages something. I'll come. Let me collect the keywords. Okay. Now 4 pods. 4 pods. How these pods got created? Because of
Deployment object.
okay, I'll decode it now. Now four pods are same pods or different applications?
Different pods.
Okay. One is the mobile pod, one is electronic pod, one more like
Clothing.
clothing, one more is cart.
Yeah.
Okay, now tell me 4 pods. Now how many deployments we need to do deployment for this?
4.
4
4
deployments.
deployments will be there. Yes. Let's go. Let's keep it here. This is the one. 4 deployments will be there. Oh. Sorry.
Why 4 deployments?
Because four parts are running.
But we can keep it right in a single deployment.
You cannot keep. You cannot keep.
So
No,
in
yeah.
case-
That's my question. Why?
Yeah, the question is if there is 1 lakh, so 1 lakh deployments you have to do.
Yes. Yes. Yes.
Okay.
Yes. Yes.
There is
You
no
come.
alternate way to minimize this thing. You have to do each and every deployment.
Sorry. What is that?
Is there any other
Okay.
alternative way to?
Yeah, I'll tell you. Yes. What you can do, I can club all together in one deployment. I can club all together one deployment. If this deployment make mess,
Mhm.
you are in which world right now? This is the one. Monolithic versus micro. Now you clubbed all together in one deployment. You can do. You can write one deployment YAML only. In one deployment one deployment YAML also. I can keep image 1. You can keep image 2. I can keep all those images, mobile, electronic, and all. If there is some mistake in this deployment,
Okay, and we lost everything.
that's where. Now, if you deploy individually, if there is a problem with this,
Okay, that's where container.
Remaining all 3 will be work.
these guys will be continuous will be working, right? There is no impact, na business
Yeah.
too more.
Understand. Yeah, thanks. Thanks for the clarification.
Now I understand. Okay, there is no impact on business. Basically.
That's where. Can I go with? You can go again. You are going to the which model now again? Monolithic model.
Monolith.
Yeah. Now you come to, I'll tell you, Netflix, I think Netflix microservices, right? They are running almost all. That's where they do decouple. That's what their job. Now, if they want to release any feature, right, immediately they can release, right? They no need to wait for other people and all. I'll bring the who are very specialist in this area. We'll make it. It will be continuously will be getting deployed. There is a Netflix. I think I don't know, like more than 1,000 plus microservices they'll be using behind Netflix. 1,000 deployments. Each deployment will have individual pods. Internally, they'll have individual services objects. They will be talking internally. Yes. Now you got the question for this, you mean?
Yes, clear.
Yeah. Yes, we can club all together, but again, you are going to the monolithic. It will impact a lot. I mean, not only I told one use case only, there are others also. Better isolate. That is what the beauty. That is what you have to talk with the APIs only. Yeah. Cool. So now, yeah. Can you guys tell me now? My pod is running. Pods got created because of which object?
Deployment
object.
This deployment object, you will give it to someone as a reference, as a label. Whom?
Service.
Service.
How? There is a card.
Select
There is a card.
type backend.
Backend. This service type also, it's up to the pod nature. It's up to the pod. This pod I want to give to the end user. Then I'll go with what type? Load balancer.
Load balance.
These pods I don't want exposed to the outside. I'll go with cluster.
Cluster
Majorly, these two we will prefer. Majority times. If there is a separate use case, then I may go with headless, which is called none. Or I may go with node port, very rare. Very rarely we go with the node port. This thing. Now, any thoughts? You know right now. Let me go here. Let me go to the controller SSH. kubectl. How do you see the deployment? How do you see that deployment? Sorry, how do you see the pods?
Get pods. Get viewer pods.
There is a one command to see the services. kubectl get
services.
Service. You can say like this also, or you can say SVC also. There is a default one got deployed. We have not deployed. It came along with the cluster. Okay. Now you see here. How do you know service exists or not? Service is another object. This is the command SVC. Service also you can give or SVC. You see here, this is the name, which is this guy.
Cluster IP.
Cluster IP. This is the one port number. By seeing itself, you can know what is this port number. Private or public?
Private.
Private.
Private port number. So you mean to say they have their own network internally. Our VPC will be different network. Pods will be different network. They will be different network. If you make a load balancer, right here, you will get a load balancer. Endpoint here, you will get a load balancer. Let me make one YAML. Just 2 minutes. I'll make YAML. Service type load balancer AWS EKS example. Give me one YAML. Let me go to that YAML. They'll give YAML. Service. Example. You have to tell me here. 2 minutes will leave. Okay. What is the one they're deploying here?
Deployment.
Because of this, what will get created?
Pods.
Pods.
By seeing this, how many pods?
3 parts will be.
3.
Pods. Replica.
That's what the skill set. You no need to be master in writing YAML. No. This is what you need knowledge. That's it. No. This is what is the deployment name here? This is the
NLP sample app.
that is the one. Now, which image they are deploying? What is the image?
Public ECR, Nginx.
Nginx.
What is the port application is running?
80.
That's what. This is the skill set. When you read a deployment YAML, right? This is the skill set you should have it. What is the deployment name? How many replicas? What image they are running? That is what. Now.
Service.
Anna, a doubt, Anna.
Yeah.
I have one doubt.
Yeah.
That name and image name both should be the same, no? Here. The containers image name.
No. This can be any name. This can be any name. But
okay.
This can be any name. Somewhere this one, right here selector.
Yeah.
Somewhere something should match. You see, right? App and this, na? These two should match.
App name and the container name.
You see, right here, app : engine, app : these two should match. This can be any name.
Okay.
This can be container name, can be anything. No, these should you see, right? App : Nginx. These both should match.
Okay, fine.
Label should be matched, right?
Yeah, this match labels. You are calling here labels, right? These should do match.
Yeah, both labels should be.
Yeah. Now, this is the beauty. What is the object?
Service.
Now,
type is load
balancer. You can access outside.
No. Service will select whom?
Deployment. Which object?
This is what here. You will see right here. Service is selected to whom?
Nginx.
Now you go top, little top here. Somewhere app : Nginx is there. Na? Here.
Right.
Here. This one. This is the name. This name should match. Now who will get created here?
Load balance.
Automatically. Target port is nothing but your container port number. The service port also they're saying 80. Now here, right? Here, let's see what load balancer they're going. Little left side.
NL.
Here, yeah. What load balancer they're going here?
NLB.
Automatically, one NLB will come for you. This is where I was telling, right? In the annotation, you can specify. You want to go with the NLB or ALB, something you can go here. Now let's see. Load balancer will come. No, I don't want to go with the NLB for it. We'll take one more. Let's take these examples. Take this example. Let me take one more. Yeah, just a minute. We're done. Now one more here also. What is the service type?
Service.
Where is the deployment getting selected here? Where is the deployment getting selected?
Last.
In spec there will be a selector.
App user,
This is your deployment.
Yes.
Yeah.
This is whose port number? Your container port number. So application they are running on which port number here? 80
8095.
8095. One more. Where is the deployment for this? 1 second. Sky. So this is the, let me click on the blue. Yeah, this is the deployment. You see here, this is the container. This is the container image they are running. Here one image they are running. And which port number they are exposing here? Somewhere port number will be there.
8095 down.
They should get matched. Third service. Oh my God, one more node port. One more load balancer. So we'll take this simple example. We will change it to according to our format. Okay, we'll change this. Let's take this ML. I need working one ML. We'll give this link also. I clicked on the fourth step. Here in this link, fourth step. Okay. So we already have a deployment. You have to tell me how to change it. This is the deployment we deployed. This is the one only. Now, one more ML. What is that ML?
Service.
Oh, already is that. Here. So let remove this guy. This guy. Metadata, it's up to you. Now, this selector should match with your
Deployment
in the deployment name also,
Label name.
Static website.
this name app colon.
Name is static. Select me.
That's it. That's it. Here target port is what is our application?
80.
Say that
Static website.
service. Let's remove these ones. Let's remove one also. Yeah, save this. Bring this YAML. Let's apply this YAML. Oh my God, why what happened? Let me take a new session. Just we will apply, we will leave for today. Let me go for that folder, workspace folder. Here I'm keeping a folder, right? Everything here. VI. YAML. What is the object we are going to create now?
Service.
As load balance service.
Service. kubectl.
Apply FNI.
How do you check service got created or not? What is the command?
kubectl
Get service. Get SVC.
Okay, let me. Somewhere you see.
Yeah. Load balancer.
static.
Static website service.
Next, what is the type?
Type is load balancer.
Load balancer.
Next,
IP address.
some cluster IP. Next, you see here what got created here. What is
External
it?
IP. External IP.
By seeing this, you can come to know what is
Load
this. Type.
balancer endpoint.
If you go to AWS console, right, load balancer got created automatically. You don't need to touch anything. Here is the port numbers also getting managed. This in the Docker run, right? We used to map, right? Docker run, blah 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 something. Now
Yes.
Kubernetes will take care of that. What is this port number and done? Now your job is to just access this. Let's see. It takes some time, right, to register load balancer. This is not the error timeout and all. This is DNS is taking time to register in their AWS DNS people. Yeah, this is one. Now, this service, now load balancer will send to whom internally? This load balancer got created because of which object? Service object.
Service.
Service.
Service object selected whom? Deployment. Because of the deployment, who got created? Pods. This load balancer internally forwards to those pods, internally to those worker nodes also internally. Internally, the kube-proxy will manage behind. That's Let's pass it here. We'll continue tomorrow. Thank you.
Thank you.
Thank you.